All right, so this is our second video on the transformation of exponential functions. In the first video, we learned three rules that predicted the way a graph would change or transform based on identifying certain modifications to the equation. Now, if you have not watched that video, if you don't know what those three rules are, then nothing in this video is going to make sense to you. So if you haven't already watched video number one, make sure you pause this right now, go back and watch that other video, then come back to this one, okay? But if you have watched that other video and you're familiar with those three rules, what we'll be doing in this video is looking at problems where there's more than one of those rules happening at a time. And so we're gonna have to sort out, how do I know which rule to do first, and how do I have this sort of cascading effect of rule after rule after rule. All right, so with that said, let's get started. Only one learning objective in this video. That is just simply to be able to apply the rules when there's more than one going on. That's our learning objective, all right? So let's start with just a very, very quick review of what those rules were. So this is how you're gonna know whether or not you're ready for this video. So we talked about in the last video three rules. I'm going to just write these in the order that they come to my mind. This is probably not the same order I did it in the video last time. That's okay. The first one that happens to come to my mind is what we call a horizontal, I can't spell, horizontal, there we go, translation. And then secondly, we talked about a vertical translation. And again, this might not be the order we talked about them in the video. And then last, a vertical reflection, okay? Now, if those three names sound familiar to you and you have a basic idea of what I'm talking about right now, you're good to keep watching this and you're ready to roll. But if you have no idea what these three things are, if you've never seen this before, go back and watch that previous video. Otherwise, this one's not going to make any sense to you. All right, so you should right now be comfortable with how these three rules work. And we're going to use all three of those rules in this particular video. But there's going to be situations in this video, every situation, where there's more than one rule present. And so we have to deal with, what do I do when there's more than one thing? Okay, well, in some areas of life, when there's more than one thing, you just stir it all up together and you deal with it all at once, right? That's like, I don't know, that's the way we deal with stuff when we're cooking, right? I got some sugar, I've got some flour, I'm gonna mix it together and use both of them all mixed together at once to make cookies, right? That's the idea. Math doesn't work that way. In math, when we have things that are all mixed together, what we have to do is we have to sort them out and deal with them one at a time. And when we do that, it's important that we deal with them in a consistent order, because changing the order changes the answer, generally speaking. So to help us deal with problems, where there is more than one transformation occurring. Okay, to help us deal with problems where there's more than one transformation occurring, we need something to help us sort them out. Well, the rules will sort themselves out, right? Remember, for example, this rule dealt with things that are happening to the x, but this rule dealt with things that are happening to the function, to the equation. It'll be easy for me to tell those two things apart. So sorting them out is not going to be the problem. The problem is going to be knowing what order to do them in. So to help us with problems where there's more than one transformation occurring, we will use the order of operations to determine which transformation to work with when. Okay, so when do we do which one? In what order do we do them? We're going to use the order of operations to figure out what to do when. Okay, That's the idea. In order of operations is nice because that's something we already know. So technically, we're not learning anything new in this video. We already know these rules. We already know the order of operations. All we're going to do in this video is put those two things together. All right. So with that said, I'm going to look at the exact same function that we looked at in the last video, y equals 2 to the x. So in the last video, what we did was we took this and we used this to make a graph of some other function. So for example, let's say 2 to the x minus 1, something like that. Okay, so I'm going to use this graph to make that graph. That's what we did in the last video. Well, there's only one transformation occurring there. Hopefully at this point, you're comfortable with that. But now in this video, we're going to have a second transformation occurring. And so I've got to know how to handle it when there's two transformations. So what I've just suggested is we're going to use order of operations to help us. So in this problem, I've got a minus 1 that's in the exponent, and I've got a plus 3 that's just tacked on to the end. Well, notice that the minus 1 is literally in the exponent with the x. In other words, those two things have been grouped together. They've been put together inside of the exponent. Even though there's no grouping symbols, there's no parentheses or anything like that, they have been grouped together in the exponent by the mere fact that they're both small and written up in the air that way. So this is going to be the thing that we do first, because they're inside of a grouping symbol. And we know order of operations tells us to simplify the things inside of grouping symbols first. So we're going to deal with that transformation right there first. And I'm going to use my blue pen to deal with that transformation. Then once we're done with that, we'll have to handle this plus 3 that's added on to the end. Obviously, since there's only two transformations, if this one's not first, well, then this one must be last. Okay, so that's going to be the next thing that I'm going to do is I'm going to deal with that plus 3. And I'm going to use my purple pen for that. So I'm going to start with a red graph. I'm going to turn the graph into a blue graph by dealing with this minus 1 transformation. And then I'm going to turn that into a purple graph by dealing with this plus 3 transformation. So I'm going to have to do this in two parts, in two movements. And when you get practice with this, as you get familiar with this, you'll probably be able to do this middle step in your head. You probably won't have to do it all the way I'm going to do it right now. But since we're just learning, I'm going to actually do it in two parts and draw each part for us. So the first part is I'm subtracting 1 from x. So if you go back to our rules from yesterday, we know that whenever you add or subtract from x, that causes the graph to do a horizontal translation. It's going to slide either to the right or to the left, one or the other, okay? If I'm subtracting 1, that was a situation where the graph moves to the right. So it's going to move to the right 1 unit. So this point that was at 3, 8 is going to scooch over 1 unit, and it's going to be right there now. So if it was at 3, it scooches over 1. Now this is at 4, 8. Okay, so that's what's going to happen to that graph, or that point. And that's going to be what happens to every point. So this point's going to scooch over 1. This point's going to scooch over 1. Every single one of these points is going to scooch over 1 spot. And when I connect those dots, what I'm going to end up with then is a graph that's the exact same shape. If this was geometry class, we would say they're congruent, but it's been scooched over 1 unit to the right. So there's my first graph. Now, for the second piece, the plus 3, that's being added on to this equation. That's the equation that 3 is going to be added onto. So when I take care of this plus 3, it's this blue graph that's being modified. It's this blue graph that has the plus 3 on it. So now I'm just ignoring the red graph. It's like it's not even there. And I'm going to work with the blue graph. So plus 3, because I'm adding it onto an equation, that rule said we're going to move up or down, one or the other, a vertical translation. And because it's a plus, that was move up. So this thing that started at 3, 8 is going to move up 3 places. I'm sorry, it was at 4, 8, because I'm looking at the blue graph, 4, 8. But now it moves up 3 places. So now it's up here at 4, 11. Okay. And then the same thing is going to happen to this. It's going to move up 3 spots. So now it's here. This one's going to move up 3 spots. So now it's here. This one moves up 3 spots. So now it's there. And likewise with this one. Notice with these, just like we talked about yesterday, when they move up 3 spots, there's some fraction that they're moving up. Okay. And the result is that now my graph is kind of bottoming out way up here and then curling up from there. So another thing we talked about yesterday is functionally the asymptote has moved up 3 spaces also. In fact, I'll be honest, usually when I do these problems and I have a vertical translation, the very first thing I do is I draw in my new asymptote. That tends to help me. Okay, so there's my new asymptote, 3 spots up. Okay, so that's our basic process. So this blue, that's just my first step. That's not my final answer. This purple graph, that's my final answer. Because that has both moved over 1 and moved up 3. It's done both of those. Okay. All right. So this is the basic idea. Let's take a look at another one real quick. And this is going to be a problem where it has a reflection and a translation. So now we're going to graph y equals the opposite of 2x plus, let's make this one minus. Let's make this one minus. Minus 5. Okay. The opposite of 2x minus 5. So think about order of operations here. Should I do this multiplying by -1 first, or should I do this subtracting by 5 first? Well, we know in order of operations, multiplies come first. So that's the first thing I'm going to do is change my graph based on this multiply. And then when I'm done with that, then I'll make my movement based on that -5. Okay, so for the multiply, we know that it's going to cause it to flip over the x-axis. All of my y coordinates, they were positive. Now they're going to be negative. So this +8 is going to become a -8. So over 3 and then down 1, 2, 3, 4, 5, 6, 7, 8. And this over 2 up 4 point is now going to be over 2 down 4. This over 1 up 2 point is now going to be over 1 down 2. Okay, 0, -1, -1, -0.5, -2, -1/4. So when I do my first transformation, I'm going to have this reflection right here. So that's my first stage or my first step. Okay, but now I need to deal with this -5. So what does a -5 do when it's a -5 to the equation? Well, when we work with the equation, it moves up or down. And when it's a minus sign, it's going to move down. So and it's being subtracted from this whole thing that I just made. So I'm going to take my blue graph and I'm going to move it down 5 spots. So completely ignoring my red graph, my blue graph moves down 5 spots. And I'm going to do this the way that I would actually do it personally. The first thing I would do when I move up and down is move my asymptote. My asymptote is going to move down 5 spots. So it was at the x-axis. Now it's at 1, 2, 3, 4, 5. So my new asymptote is going to be right there at y equals -5. That's going to be my new asymptote. Okay. Now, each one of these points is going to move down. So this point right here, the reason I like to do my asymptote first is now I don't have to count. I can just compare it to the asymptote. This thing was a quarter below the asymptote. So it's just going to be a quarter below the asymptote down here now. This thing was half below the asymptote. So here's my asymptote, go down a half. There's my new point. This was 1 below the asymptote. So here's my asymptote, go down 1. There we go. But you can still move the point if you want to. So this was down 2. And now I'm going to move it 5 more. 1, 2, 3, 4, 5. And it's there. Notice it's still down 2 from the azimuth. Okay. Here, if I move this down 5 units, 1, 2, 3, 4, 5. Okay, this point was 4 down from the azimuth. The new point is also 4 down. So you can do that either way, whatever makes more sense to you. 1, 2, 3, 4, 5, or whatever way seems easiest at the moment. So here then becomes the new graph of my new function that has both of those transformations going on. So this is the graph of y equals the opposite of 2 raised to the x power minus 5. Right? All right. So this is the basic idea. I am going to give you one final example here and ask you to try this on your own. So if you would please, again, starting with this same function, please try to make the graph of y equals the opposite of 2 raised to the x plus 2 plus 3. Okay, so that's the graph we're going to make here. So I'm going to ask you pause the video and try to make that graph on your own first. Maybe the first thing you want to do is decide what is the order you're going to do the 3 steps in. Once you've decided what order, then start the video up again and compare what you're doing to what I'm doing. All right. So what order should I do the 3 steps? All right. So hopefully you figured that out. Hopefully you know what order to do the 3 steps in. We know Aunt Sally tells us that grouping symbols come first. So the first thing that I should do is I should deal with the x plus 2. And I'm going to move my red graph 2 units based on the fact that there's an x plus 2 here. Okay, so now I'd ask you pause the video and actually do that. Pause the video and move the red graph 2 units based on the x plus 2. All right, so hopefully you've drawn this. You should have figured out that because it's being added to the x, it's going to move either right or left. And because it's a plus 2, it's going to move to the left. So all my points are going to do 2 units to the left. All my points are going 2 units to the left. Okay, so here's where all my points are now. So my graph, 2 units to the left. So there's step 1. Okay, now, same question. What should I do next? Should I deal with the minus sign or should I deal with the plus 3? Pause the video and make a decision. And once you've decided, resume the video. All right, so hopefully you've decided, and hopefully you decided do the minus sign next, right? Because order of operations says grouping symbols, which you already did. Exponents, well, exponents built into the function, so we're good there. And then multiplies come next. So that's the next thing we're going to do. All right, so now what I'd ask you to do, now, since we know that the multiply is going to come next, pause the video and actually do that. Draw the new graph that minus sign is going to make. All right, so hopefully you drew a second graph now. And what you should do is use the blue graph, not the red one, because the minus sign is attached to this thing, and that thing is the blue graph. All right, so what do minus signs do? They make them flip. So I've got this this horizontal axis. This thing was up a quarter. It's going to flip. So now it's going to be down a quarter. Okay, so I'm using the blue points. It was up a half. Now it's going to be down a half. Was up 1. Now it's going to be down 1. This blue point was up 2. Now that blue point is going to be down 2, and it's going to be purple. This one was up 4. Now it's down 4. This one was up 8. 5, 6, 7, 8. Now it's down 8. So when I finish the second step, I have this purple graph. All right. So that's step number 2 right there. Now, there's only one step left, right? We've got to do that plus 3. That's going to be our final step. So I'm going to ask you now, pause the video and do that final step right now. All right, so hopefully you've drawn your final graph. I'm going to use this kind of rust-colored pen to do this. And because the +3 is added onto this whole equation, it's the graph of that whole equation I'm going to move. In other words, it's going to be the purple graph, the graph that I got when I'm after step 2. So how is that graph going to move? Well, when you add something to the equation, it moves either up or down. And when you're adding, it's going to move up. So this purple graph is going to move up. So the first thing that I would do is I would move the asymptote of the purple graph up 3 spots. So instead of at 0, 1, 2, 3, now it's going to be up here. So this is my new horizontal asymptote. Okay. Now I'm going to take the purple graph and I'm going to move every point on the purple graph up 3 units. And just like I showed you on the last example, you can do that 2 ways. You can either just take the point and count 3 spots up, 1, 2, 3, and now that point's there. 1, 2, 3, now that point's there. Or you can compare the point to the asymptote. So this point was down 2 from the asymptote. The new point is going to be down 2 from the new asymptote. Okay, so that's a valid way to do it also. This point was down 1 from the asymptote. The new point is going to be down 1 from the new asymptote. Okay, but you can still count up. Okay, so if I count up, I'm going to go to the half units. So 1, 2, 3, that one's there. Or you can count down, whatever's easier, whatever you think is easier. Okay, personally, I tend to think that the points that are really close to the asymptote, it's easier to just count how far away they were from the old asymptote and then count that same distance for the new asymptote. So personally, that's what I do when I'm working with things that are close to the asymptote. But for these points here that were far away from the asymptote, I think it's just easier to count. I think that's just easier to count. All right, so there we go. This rust color, which on the video, I'm not sure if that even looks rusty, but whatever that color is to you, that is our final answer. So this is the type of problems you'll be doing in our next assignment. Thanks for watching. Have a good one.